linear functions and nonlinear functions. And here's your graphic organizer. Go ahead and label the 4 different sections. And here's the definition of linear functions. It is a set of points with a constant rate of change that make up a straight line. So you've already talked about a set of points, which is a relation. You've already talked about constant rate of change. And the new thing is that if it has a constant rate of change, it's going to make a straight line. This goes in the center box of your graphic organizer, and I would like for you to highlight the words linear functions. Let's go to the table section. You already have this table written, and for us to determine if it is a linear function, we're going to have to find the constant rate of change. So as you learned, we have to find the difference of the x's and the y's. So go ahead and do that on your paper. Today we're going to talk about linear and nonlinear, and if you look at both of these sides, you should be able to determine that the second side is going to be the linear side because it makes a straight line. And if you see the word linear, it has lines in it. So you have this graphic organizer. Go ahead and fill out the 4 sections. And here's the definition you're going to put in the middle. Linear functions is a set of points with a constant rate of change, and they're going to create a straight line. So let's highlight the word linear functions. Now let's go to the table section. This table's already there for you. Go ahead and find the constant rate of change for the table. So we're going to make our marks, and we find that we will have -2 for those changes, and then we will have +6 for those changes. So because we have a constant rate of change, we're going to label it as y/x and fill in our numbers. We would have the 6 because that's the x value, -2 because that's the, 6 is the y value, -2 is the x value. And when you simplify that, you get -3. So because we are able to find a constant rate of change, this would be a linear function. So here is our answer. Linear, the constant rate of change is -3. And let's highlight that answer because that's how you're going to answer your questions on your homework and on quizzes and tests. Linear because there's a constant rate of change, and that constant rate of change is -3. Go to the graph section. You don't have to write these ordered pairs. Just go ahead and plot them on your graph. If we plot the points -2, 3, then -1, 1, 0, -1, and 1, -3. And you should notice that it does create a straight line if you were to connect to the points. And now we can make our triangle like we were learning with constant rate of change to find the constant rate of change. If you have a hard time with that, you could also write down the ordered pairs as a table and find the constant rate of change that way. But we are going to be using linear equations for the rest of the year. Oh, this is... Now we got a little messed up. Okay, so if we go... Oh, I see what I did. Not that. Let me erase that so it looks better. So we would go up here. There we go. So we always want to do the y/x first. So we have up is going 1, 2, and over 1. Up 2, over 1, up 2, over 1. And you should first of all notice that this is going downhill. So when we write our y equals x, we want to go ahead and make sure we have a negative number. So we have the 2 and the 1, make one of them negative, or the whole fraction negative, because our constant rate of change is going to be -2. You should be able to look at this and determine that it is linear. Therefore, you would know it does have a constant rate of change. So we would have the answer as linear. Constant rate of change is -2. And let's highlight that so we know that would be our answer. So let's go to the next section, which is going to be the maps. I've created the map for you. The only thing you need to do now is create the lines, and I will let you know that I've used the same examples for the tables and for the graph. So use those ordered pairs to create your map. So let me fix it up here. 3, 1. Oh, it already is fixed, so we don't have to do that. Today we're going to talk about constant rate of change. The directions for your homework and your notes for today: determine whether the relationships have a constant pattern. If so, find the constant rate of change. So what I would like for you to do is write y over x at the top of your paper on both sides of the title. On both sides of the title, because y over x is very important. Usually, you think about plotting a point where you plot the x and then the y. This is the first time you're going to see something different where we're focusing on the y first and putting it in a fraction. So here is example 1. You already have this on your paper. We're going to find the rate of change. So I would like for you to tell me, what is the difference? What do I get from how do I get from -1 to 0? What do I have to do? Sorry. So from -1 to 0, we would add 1. From 0 to 1, we would add 1. And then to get from 1 to 2, we would add 1. Now that's the x values. Let's go down to the y values. We're going to start from this side because that's what we did before. To get from -2 to 0, we have to add 2. To get from 0 to 2, we have to add 2. And from 2 to 4, we have to add 2. Because we see a pattern for the x and a pattern for the y, we know this is going to have a constant rate of change. So for that, we're going to write y over x every single time. And the y constant rate of change is +2. And the x constant rate of change is +1. And 2 over 1 equals 2. So our constant rate of change for this example is 2. Here is example 2. We're going to again start by finding the rate of change. So let's start with this. To get from 0 to 2, I'm going to add 2. 2 to 4, I'm going to add 2. And 4 to 6, I'm going to add 2. Looks good so far. Let's go to the y values. To get from 5 to 3, you're going down, so we're going to subtract by 2. To get from 3 to 0, you're going to subtract 3. And 0 to -4, you're going to subtract 4. Even though we see a pattern, it is not constant. So this one does not have a constant rate of change. So in this case, our answer, we would write the sentence, does not have a constant rate of change. And put a box around that. You will use that on your homework and tests and quizzes. For example 3, notice that we're not dealing with just X and Y. We're actually dealing with cards and the amount of money for each card. So let's, like before, find the constant rate of change. So from 1 to 2, we would add 1. 2 to 3, add 1. And 3 to 4, add 1. Go over to the other side. To get from $1.50 to $3, we would add $1.50. To get from $3 to $4.50, we would add $1.50. And from $4.50 to $6, we would add again $1.50. Because we have a constant rate of change on the y and the x, we're going to go ahead and write y over x. And I'm going to put an x next to the cards and a y next to the total cost, so I remember that those are my x and y values. Because I need the y value first, and it's positive 150, I'm going to put that as my numerator, and my denominator is positive 1, and that is going to equal 150. So we need to now write out, what does that 1.5 mean? The y value represents money. The x value represents cards. So if you look at what we have dollar per. Think about that fraction symbol as per card. So we would have dollar and then per card. And that would be your answer. Okay? Let's look at example 4. So we again have the x and the y. And you should have already done this, but we are adding 1 each time. And then over here, we would have plus 8. Then you would have plus 6. And then plus 4. So we can easily see that we do not have a constant rate of change. So our answer is going to be, with a box around it, does not have a constant rate of change. Let's look at examples 5 and 6, which are graphs. So these we're going to do a little bit differently. On your homework, you're not always going to have these points, even though we've given them to you on your notes. So sometimes you'll have to plot them yourself based on the line that you've been given. So I'm going to put x here and y here. And now we're going to use something we used in Unit 2 with Pythagorean theorem, where we are going to make a triangle that connects our points. After you make your right triangles, we're going to number them. So we have one bubble going up here, but what you have to look at is one bubble equal to the number 1? And it's not in this case because we go from 0 to 30. So I'm going to go ahead and fill these numbers in so I have them, because it's going up by 15. So I know one bubble mark is actually representing the number 15. Then if I look at the part going sideways, I have 2 bubble marks. Let's see what that represents. And we have 0, we have 1, 2, 3, 4, 5, 6, and 7. So that is increasing by 1. So these bubble marks do represent 1 each. So that would mean 2. And I can look, and I know this is going to be 15 again, and 2 again. So it does have a constant rate of change. So we can write y over x. And I'm going to put my words in my fraction. My y is miles. Miles. And my x is inches. Now I can fill in my numbers, and I have to think about which one is y and which one is x. Well, I know y goes vertically, and my vertical number each time is 15. So that means 15 is going to be the numerator, which leads to, and it goes in the x-axis direction, is going to be my denominator. And if I take 15 divided by 2 in my calculator, I can get 7.5. So 7.5 represents miles per inch. And that would be your final answer. Now let's look at the last example, example 6. You should now know that this is going to be a constant rate of change because it makes a straight line. I'm going to find the points because I did not give you any, or I did actually on your notes, just not up here. I can find points wherever it crosses at an exact order pairs where I can put a dot. Now I know that this is y and this is x. This is going to be my right triangle. I see that it's doing the same thing each time, so it has a constant rate of change. So now I need to look. What's happening? This bubble mark represents 10 because it's going up by 10s on the y-axis. The x-axis, if I fill in the numbers, is going up by 1. So I know each one of these bubbles is a 1. So I have 10 and I have 5. So let me fill in the words. Y is degrees Fahrenheit. X is hours. Now let's fill in the numbers. The y is going to go this direction, and that number is 10. The x going this direction is 5. If I do that division, I get 10 divided by 5 is 2. But what I want to notice is this one is going downhill. So that means it's decreasing. So I'm going to put a -2. And it is -2 degrees Fahrenheit per hour. So box that answer.